Okay, now let us look at the equations we use for projectile motions. Okay. First of all, okay, we know that projectile motion has two components, the x component and y components. Okay, the x component is a constant velocity, the y component is a free fall motion. Okay, we have several things to investigate: the acceleration, the velocity, the displacement, and the time taken. Okay, and first and foremost, we learned about acceleration for x component and y component. We know that x component is a constant velocity. That's why no acceleration, or we can say ax equal to 0. Remember, this is the most important thing. Ax equal to 0. Okay? For y component is a free fall motion. It is affected by gravity. So ay equal to negative g. This is actually the most important points in projectile motion. Remember, whenever you see a projectile motion questions, you must remember these two things. Ax equal to 0 and then ay equal to negative g. If you know this, then you can solve all the other problems, right? Now, looking at velocity, displacement, time, how to get them, how to get the value for velocity, displacement, and time. Still remember this formula? Do you familiar with them? Of course, these are the most familiar kinematics of linear motion equations that you have learned before. Where is it? Yeah, these are the ones. In uniformly accelerated motion, we already learned about v equal to u plus at, s equal to half u plus vt, s equal to ut plus half at square, v square equal to u square plus 2as. We just use back the same formula for projectile motions. We use back these four formulas even for the free fall motions. Even for the free fall motion, we use back the same formula. Okay, just substitute the a equal to negative g. Now for projectile motion, we also use back the same formula. V equal to u plus at, v square equal to u square plus 2as, s equal to ut plus half at square. These are the kinematics formula. We use back the same formula for projectile motions. Okay, so there's nothing, we can say nothing extra you have to learn about projectile motion. What you have to know is projectile motion, you have to do by two components. You have x component and y components, and you separate the question into two parts to solve for each part. Then you can find the final answer. You understand? You do the x component and y component separately. And these two components, they are only linked by the time taken. Because why? Because these two components, they happen simultaneously. Okay? These two components, they happen simultaneously. That's why they have the same time. The time taken for x component, the time taken for y component, they are the same. Still remember about the animation I show you? Okay, we can say the time for all components is the same. You see, the time for x component and the time for y component, same. Begin, stop, begin, stop. They begin at the same time and stop at the same time. They have the same time. The time for x component and the time for y component are the same. Alright? Okay? So the x component and y component, they have the same time. The time in the x component is equal to the time in y components. Okay? You must remember this thing. So we use back the same kinematic formula to solve for each component. You see, in x component, we know that ax equal to 0. Alright, so we substitute ax equal to 0 into the acceleration in each equations. What will happen if we substitute acceleration with 0 for x component? So when we substitute acceleration with 0, at becomes 0 because 0 times time, you get 0. So when this one at becomes 0, v equal to u. So for s component, the final velocity, the final s component velocity is equal to the initial s component velocity. Similarly to v squared equal to u squared plus 2as, we substitute a equal to 0. What do we get? We also get vx equal to ux. You see, we square root both sides. We square root both sides. We also get back the vx equal to ux, because why vx equal to ux? Because the s component is a constant velocity. That's why the final, this v is actually called the final velocity, is equal to the initial velocity. The final velocity, the final x component velocity is equal to the initial x component velocity, because the velocity doesn't change. The velocity doesn't change. That's why the final velocity equal to the initial velocity, because the velocity is constant, velocity unchanged. Okay. That's for s component. And then if we also substitute a equal to 0 in half at squared, what will happen? So 0, you 0 everything here. Half at squared becomes 0. So s equal to ut. That means this s is the s displacement, x component displacement, and u is the s component velocity, s component initial velocity. So we got s equal to sx equal to uxt for x component. That's for x component. We use this formula to solve the parts for x component. And then for y components, we use another formula under the conditions of ay equal to negative g. So you see, okay, I rub this off. Okay, now for y component, we also use back the same kinematic formula. Okay, we just substitute ay equal to negative g. So what will happen if I substitute a equal to negative g into v equal to u plus at? Yes, I get v equal to u minus gt. A become negative g, so it become negative gt. So this all the v is the y component velocity. The final y component velocity equal to initial y component velocity minus gt, because the y component is like a free-form motion. Do you see this this formula is actually the same as the free-form motion formula that we learned earlier? Yeah, where is it? You see that this is about the free-form motion. Yeah, the free-form motion. We also use the kinematic formula. Substitute a equal to negative g. We get this formula, v equal to u minus gt. You see, v squared equal to u squared minus 2gs. So this one we also use for the y component projectile motion. And the y component for projectile motion, we also use this formula. Okay, look at here. Exactly the same formula. A equal to negative g, we substitute into here, we get this formula, exactly the same formula like the free-form motion formula. Okay, v squared equal to u squared minus 2gs, the a become negative g. Yeah, and then yeah, just highlight, yeah, this a we just substitute with this one. The a here substitute with negative g already, negative g. You see that? I substitute a with negative g. Okay, s equal to ut. To find the displacement, we use s equal to ut minus half gt squared. So very simple. We want to find, let's say the question, we want to find what's the x component velocity at any point. Yeah, x component velocity at any point. This is the formula vx equal to ux. What's the y component velocity for any point at any time? This is the formula to use to find the y component velocity. Let's say I want to find the x component displacement, the horizontal displacement at any point. Just use s equal to sx equal to uxt. What is the vertical displacement at any point of the projectile motion? What is the x component? What is the No, what is the vertical displacement at any point of the projectile motion? What is the vertical displacement? What is the height? What is the height at any point of the projectile motion? We use this formula, Sy equal to Uy t minus half g t squared. Okay, very simple. And sometimes the questions will link to each other. These two formula will link to each other. Let's say maybe the question will give you this one, they give you this one, okay, and this one, and then it will ask you about this one. Want to get Sy, right? Want to get S, and it give you Sx and Ux. It give you Sx and Ux and ask you to find Uy. How do you do that? Very simple. The way is, the key is, you use this formula. You use this formula to find the time first. To find the time first. And once you got the time is equal to the y component time. And y component time, you just substitute into the time over here, and then you can get your Sy. You see that? That's how we link between two components. We link between two components with the time taken, because the time taken is they happen. These two components happen simultaneously. Do you see that? It began, stop. It began and stop at the same time. They have the same time. The simultaneous motion. See that? They have the same time. So Tx equal to Ty. Okay. Give you Sx, you find time. Got time in x component. You substitute for the time in y component because they are equal. Okay. And then once you got the time, yeah, just substitute into here. You get Sy. That's how you do it. The same goes to you want to find, let's say, the Vy. Also, we use the time. Okay. Now look at these. These are the most common thing we do in projectile motion. Normally, the question will give you the initial velocity and the angle theta. Yeah, maybe he give you the velocity, velocity 10 meter per second. Initial 10. A ball is being thrown at initial velocity 10 meter per second at an angle of 30 degree from the x-axis, or from horizontal, above the horizontal. Yeah, you throw a ball at 10 meter per second at 30 degree above the horizontal. So ask you to find the final velocity. Can you find it? Very easy. So what you have to do is the initial velocity, you have to resolve into two components. This procedure, I will show you more videos on problem solving regarding projectile motion. You must look to the videos for problem solving in projectile motion to understand clearer about the steps taken to solve the projectile motion questions, right? Please refer to those videos about problem solving in projectile motion. Okay, first of all, basically it's like it gives you the initial velocity 10 meter per second at an angle projected at an angle 30 degree. So what you have to do first is you must resolve this initial velocity into two components, into the x component and the y components. Okay, so this velocity has two components, ux and uy. The ux is using cosine theta, u cos theta, y cosine, because this is adjacent. Because ux is adjacent. Okay, adjacent. Ux adjacent, so that's why I use cosine theta. Uy using sine theta because it is actually the opposite. It is the opposite. Yeah. This uy is actually the opposite. You see that? The opposite. So that's why this one use sine theta, because opposite use sine. Okay, opposite use sine theta, or we can say got angle cos, no angle sine. That's all. Okay, so you must resolve the velocity into x component and y component velocity. After that, now you already have ux and uy. Okay, you already have ux. Just want to rub all this off. Now you have the ux and uy already. Then you can perform equations like this, and you have uy to substitute here. You can perform equation like this formula, like vy equal to uy minus gt. One thing we must know, ay is always negative g. We substitute ay equal to negative g, and you can find the time. You can find the velocity also. Okay. Sometimes the question maybe require you to find the initial angle, initial projected angle, and then you will need to use the tangent theta equal to uy, opposite over adjacent. Opposite over adjacent, you get the tangent theta to find the maybe you got some question want you to find the angle theta, the initial angle. The initial angle. Then you use this formula. And then maybe the question asks you to find the final velocity at any point. Find the final velocity at any point. So what you have to do is you cannot straight away find the final velocity. You must first find the what is the final x component velocity and what's the final y component velocity. Then we do Pythagoras theorem, square root. Then only we can find the final velocity. And remember, projectile motion is a two-dimensional motion. It has two components, so you must find vx and vy. Then only you can find v. This v has two components. Okay. What I'm trying to say is, you have the ux initially. Okay, ux is actually the same as vx. So you got your first vx. You see, just want to highlight it. Now you get your first vx. Okay. Now and then and then you from here uy, you got your uy. You just use this formula, substitute, and then you get your vy. You see, you get your vy. Then you substitute into here vy. Then you can find your final velocity. You understand or not? Then you find your final velocity. That's it. Okay. You must do Pythagoras theorem, and then you also need to find, because this is a vector. This v, this v is a vector. Velocity, this is we call it velocity. Velocity is a vector. Vector, you give magnitude not enough. You give magnitude not enough. You must also give the direction. Don't just give the answer in magnitude. You must also include the direction. Then only you get full marks. So to find the direction, very easy. Just like your chapter 1, how to find the resultant vector. You find your the magnitude of resultant vector using Pythagoras theorem. To find the direction of the resultant vector, you use tangent theta. Means opposite over adjacent. Opposite is the vy over adjacent vx. Modulus, make it positive value. Then you can get a theta angle from x-axis. Always we refer from x-axis. We never refer from y-axis. We always refer from the theta angle. We always refer from x-axis. Like for this case, this theta degree, you need to say that this is theta below positive x-axis. For this example, this is theta degree below positive x-axis. You don't just give the angle theta. You must also mention below or above the positive x-axis. Okay. So remember, the final velocity, don't just give the magnitude. You must also give the direction. Okay. So very simple. Remember this x component, ax is 0, y component is ay equal to negative g, and these two components always link by using the time taken, because tx is always equal to ty. Once you got the time from the x component, you can use the time for y component to get the rest of things. You can get the displacement in x, displacement in y. Similarly, you also can do the other way around. From the y component, you also can get a time. So can get a time, and the time you can use the time in y component. You can use for the time in x component, and then from the time here you can find the, let's say, horizontal displacement. So it's either from X component, find the time, go to Y component, or from the Y component, find the time, go to the X component. That's the process mainly for projectile motions. Okay, let's continue to the next video.